In this episode, change of base formula coming up back into action. Hey guys, today I will show you how to use change of base formula for logarithms. That basically says that any logarithm to the base a can be rewritten as a fraction of two logarithms with a new base, let's say c, provided that a and c, they are not equal to 1 and they are greater than 0 since they are bases. Now, suppose you are given log to the base 4 of 8 and you need to evaluate, you need to find the value for that log. So we could basically use this formula, change of the base formula. All you do is just rewrite it as a two logs being divided, and your argument, which is 8, your large number, goes on top, and your base number, which is 4, goes on bottom. Now, what base should I pick? Well, you could pick basically any base as long as this number holds the same. But in this case, you could go for 2, since both 8 and 4, they are divisible by 2. So if I pick 2, so 2 is my new base. And all I need to do is just figure out top and figure out bottom. So all you need to do is just ask yourself, what power this little base 2 has to be raised to produce this number 8? And the answer is 3, since 2 cubed gives you 8. So this exponent, so logarithm always gives you the exponent of this exponential version. So this 3 is needed to make 2 into 8. So top number, it simply becomes just 3, and we could write it. And the same idea, the same trick applies for the bottom. Just ask yourself, what power this little 2 has to be raised in order to produce this 4? So what power 2 has to be raised to produce this 4? And the answer is 2, since 2 squared, or 2 times 2, leaves you 4. So this exponent 2 is needed to make 2 into 4. So, and the answer is 3 over 2. So that's your final answer for that logarithm. Now, suppose you are given that problem, log to the base 2 of 7, and you need to evaluate this logarithm. Well, you could try the definition of the logarithm and that relationship between logarithms and exponents, and you could try to rewrite it into exponential form and try to figure out that exponent that this base 2 has to be raised to produce this 7. And to be honest with you, I can't think of that neat and integer number that would work for that logarithm. So you need to try another technique. And at this point, change of the base is your best friend over here. So all you do is just rewrite this logarithm with a new base. And the question that can be raised over here is what base should I pick? Well, if you look at your calculator hopefully has two buttons. Just log without any base, something like this. And there is another button, it says ln. So the first log, it's basically the official name for this log, it's a common log, and the base implies to be 10. It's assumed, unless otherwise stated, to be 10. So the default is 10. And the second log, which is called a natural log, is just the log to the base e. E is a special number like pi. It's a special number in maths. It's approximately roughly 2.71 and blah blah blah. It goes on, it keep going on forever. It's infinite, non-repeating decimal. Now, basically these two buttons you can use to calculate, to evaluate logs, either to the base 10 or base e. So, if I rewrite this log, let's say to the base 10, so you would simply write log, and this larger number goes on top of your fraction, so 7 goes there, and your base number goes on bottom of your fraction. So I'm not going to write any base here since it implies to be 10. So I'm going to pick this common log for that new base c. So it's not explicitly written here. And all you do is just grab your calculator, your scientific or your graphing calculator, and you punch these two logs, and you need to find the division. Whatever decimal you get, it would be the answer for that logarithm. Well, the same goes for ln. You could also pick ln. It doesn't matter. You could either pick log to the base 10, common log, or natural log. So in the same way, you could pick ln. So e is to be base for your logarithm. So, and 7 goes on top, and the old, let's call it old base, goes on bottom. And you could also punch these two logs, natural logs, into your calculator. You could plug it in, and whatever decimal you get, so basically it has to be the same number, it would be the answer for that logarithm. Right. Well, change of base formula can be used when you are given a multiple logs with different bases and you need to come up with the same base. I will show you what I mean by that. Suppose you are given something like this. You have 3 logs with different bases being multiplied together, and you need to evaluate this entire log. Alright, since, as I mentioned before, you have 3 different bases, so all you want to do is just get and rearrange it to the same base. And the question that can be raised here, what base should I pick? What base should I go for? And basically, again, you could pick any base you like. You could go either for common logarithm, so for the base 10, or for the natural logarithm, or you could pick any other number that you like. Take your pick. So I would go for common log, so since you don't need to write any base, that's my point. And I'm going to rewrite all these three logs with the new base 10. So basically I'm going to drop it off, since for common log we don't write any base, so the default is 10. So for the first one, I would simply get log 8 goes on top and 3 goes on bottom. Gets multiplied. For the second one, 9 goes on top, so as a good rule of thumb, so the larger number goes basically on top and the base number goes on bottom. And for the last one, 7 goes on top and 8 goes on bottom. So again, I did rewrite everything to the base 10, but since we don't write this base 10, I mean, you could write it, but this is the default. This is the definition of the common logarithm, so it's implied to be 10. It's understood to be 10. Now check to see, since we have multiplication between these three numbers, we could simply cancel the same terms, look, the same numbers. So log of 8 and log of 8, they would just magically cancel and they go away, they disappear. Same goes for log 7. And now we have log 3 and log of 9. Since 9 can be expressed as a 3 squared, let's replace this 9 with this 3 squared. So what's left over is log. So instead of 9, I'm going to write 3 squared and log of 3 on the bottom of your fraction. And since I have 3 squared, so this power we can simply drag down in front of your log by using a power law, a power property, or a power rule, if you like, for logarithms. So we drag down, we pull down this power 2 in front of your log. So it becomes just 2 log of 3 over log of 3. And since you have the same number and it's actual number, if you punch it, if you plug it into your calculator, you would get a decimal for that one. So you could just again cancel that out. And you would be left with just 2. That's so beautiful answer after all this shocking work by using this algebra. So that's 2 is your final answer for that log. So it just evaluates to 2. Alright, I hope it helps you. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave a comment down below and smash that subscribe button so you will not miss out my new